The first type of trigonometric integral refers to sine raised to the nth power times cosine raised to the nth power. There are three cases in type 1. We already discussed two cases in the previous video. The first case is when the power of cosine is odd. The second case is when the power of sine is odd. This video we will do case 3 when the power of sine and cosine are both even. So not odd power anymore when they are both even. So when they are both even, then you have to take the advantage of the double angle identity. So there are three blue double angle identities. So the first one is sine square. We have one for cosine square, and then we have one for sine times cosine equals to 1/2 sine of 2x. So how do they get this double angle formula? So first of all, let's talk about this one, the cosine square x. So the cosine square x came from this double angle formula right here on your right hand side. So we start at cosine 2x equals to 2 times cosine square x minus 1. So all we have to do is we add 1 on both sides, and then we divide both sides by 2. So that's how we isolate the cosine square on one side. So if you look at the double angle identity on the left, how do we isolate a sine square x? So we started at cosine 2x equals to 1 minus 2 times sine square x. So the way we do this is we subtract 1 on both sides, and then we multiply. Sorry, let me do this again. We subtract 1 on both sides, and then we divide both sides by -2. So that's how we get the sine square x. The last one is easy. The last one, you start at sine of 2x equals to 2 times sine x times cosine x. All you have to do is you divide both sides by 2. So these double angle identities came from your trigonometry class. So we have three integrals to deal with. Let's start at the first one. So the first one, clearly they are both second power, so they are both even. That is a case 3. So for case 3, we have to rewrite the sine square and the cosine square. We have the formula in blue for you. So let's do that. We have integral from 0 to pi over 2. The sine square theta is equals to 1/2 1 minus cosine 2 theta, and then the cosine square is 1/2 1 plus cosine of 2 theta. And then you have a d theta, and then there is a 1/4, right? So let's put the 1/4 in front from 0 to pi over 2, and then you have to multiply the two products, the 1 plus cosine and then the 1 minus cosine. So after the multiplication is done, you have 1 minus cosine square 2 theta d theta. And then as you can see that this power is even, so we will have to use the double angle formula one more time. But before we do that, I have to remind you this is how it works. So for the cosine square theta, you have 1/2 and then 1 plus cosine of 2 theta, right? What if you have cosine square of 2 theta? Then this is how you rewrite that. You don't do a 1/4, that is still a 1/2, and then you do a 1 plus cosine of what? Of 2 times 2 theta, double the double angle, which is 4 theta. All right, so let's put that in red. 1/4 from 0 to pi over 2, and then 1 minus, and then that gives me a 1/2 times 1 plus cosine of 4 theta, and then d theta. Don't forget that 1/2 we subtract the whole thing. Actually, we don't really need a parenthesis right there. That's completely fine. And then you open up the parenthesis, so that is 1/4, and then we have an integral from 0 to pi over 2. We have a 1 minus a 1/2, and then a minus 1/2 cosine of 4 theta d theta. And then that is equals to 1/4. We have from 0 to pi over 2, 1/2 minus 1/2 cosine of 4 theta d theta, and now we are ready to integrate. Okay, so this one we have 1/4. The integral of 1/2 is 1/2 theta, and then this one, the integral of cosine is equals to sine, right? So that is a sine of 4 theta. But when you take the derivative of sine of 4 theta by chain rule, that produce a 1 over 4, right? Oh, sorry, that produce a 4 in front of the cosine. So therefore, you have to do a 1/2 times 1 over 4. I will just write it like this. So the 1/2 goes right over here, and due to this 4, that produce an extra 1 over 4 in front of the sine. Because when you take the derivative of sine 4 theta using chain rule, that gives you a 4 times cosine of 4 theta. So to get rid of the 4, you have to prepare yourself an extra 1 over 4. And then such that theta goes from 0 to pi over 2. And then now we can just use the fundamental theorem of calculus. So this is let's distribute the 1 over 4. That is 1 over 8 theta minus 16 times 2, 32. And then sine of 4 theta, that looks much cleaner. From 0 to pi over 2. And then you use the fundamental theorem of calculus. So that is equals to 1 over 8 times pi over 2 minus 1 over 32. And then sine of 4 times pi over 2. So that will be 2 pi, right? 4 divided by 2 is 2. So that will be a 2 pi. And then you take the whole thing minus, you plug in the 0. 1 over 8 times 0. 1 over 32 sine of 0. So this, the whole thing is equals to 0. So the whole thing is equals to 0. And then the sine of 2 pi equals to 0 as well. So this equals to 0 as well. So we only have pi over 16. So overall, the integral is equals to pi over 16. And that is the final answer to this integral. All right, we have to move on to the next one. So the next one, let's go back to take a look at that really quick. So we have the integral of the yellow one, x times sine square. And then after that, we have a cosine 4th power 2 theta. All right, let's take care of the yellow one. So we have integral x times sine square x dx. So the power of sine is odd, then we will use the double angle formula. And then according to the recipe I gave you that sine square x is equals to 1/2, and then 1 minus cosine of 2x. This is came from the double angle identity. Okay, so let's do the rewrite. We have the integral of x times 1/2, 1 minus cosine of 2x dx. And then this one, we can factor our 1/2. So we can factor our 1/2, and then that is x times 1 minus, and then distribute the x. Let's do that simultaneously, so we don't need to write another line. So that will be x times 1 minus x times cosine of 2x dx. This one, the u substitution is not going to work. You have to do an integration by parts. So if you break this down into two integral, that will be 1/2 x dx minus 1/2 integral of x times cosine 2x dx. This is a x times a cosine function, so that is clearly integration by parts. This one is definitely integration by parts. So we have to let u equals to x, du is equals to dx, and then the dv is equals to cosine of 2x dx. The v is equals to the integral of that, which is equals to sine, right? So we have sine of 2x, and then we have to prepare extra 1/2 in front of it, because when you take the derivative using chain rule, that produce a 2, all right? And then you do the uv minus integral v du. So this is 1/2, that becomes x squared 1/2 minus 1/2 times the result of the by parts. Let's put the by parts in green. So uv would be x over 2 sine of 2x minus the integral of v du, 1/2 sine of 2x dx. And then we can distribute the 1/2 and then integrate. So that is 1 over 4 x squared minus x over 4 sine of 2x. And then minus, we have a plus plus what? Plus 1 over 4. The integral of 2x is equals to negative cosine, right? So that will be a cosine 2x, and then there is a negative 1/2 in front of it. So the negative 1/2 and a 1/4, that gives me a 1/8. So 1 over 4x squared minus x over 4 sine of 2x minus 1 over 8 cosine of 2x plus c. So this is the answer to the second integral. All right, let's do the last one. What color did I use for the last one? The last one I used a purple, cosine 4th power 2 theta. Okay, let's do that. I use a purple, the integral of cosine 4th theta, right? 4th power 2 theta and then d theta. So this cosine 4th power, first of all, we have to rewrite that as square square. So cosine square 2 theta, and then we square this. So 2 times 2 is equals to 4. And then the cosine square, you can use the double angle formula. So double angle. So given in case 3, so that is cosine square of theta is equals to 1/2 times 1 plus cosine of 2 theta. If you change the theta to 2 theta, so if you have 2 theta, then that is 1/2 1 plus cosine of what? Cosine of, let's do this in orange. Then that will be these two here, these two times these 2 theta. So which is equals to 4 theta. All right, so therefore the integral becomes 1/2. Oh, and then you have 2 of this, right? So that becomes 1/2 1 plus cosine of 4 theta, and then you square this d theta. Then you have 1/2 times 1/2 is 1 over 4. I will just write everything out. 1 plus cosine of 4 theta multiply itself. Okay, and then d theta. And then you fully open up everything. So 1/2 times 1/2 is 1 over 4. And then you have a parenthesis times another parenthesis, and they are in plus. So that will be 1 plus 1 times 1, 1 times cosine plus 1 times cosine, then that will be 2 of that cosine. And then cosine 4 theta times cosine 4 theta, then that will be cosine square 4 theta. And then we have a d theta. All right, so a cosine of 4 theta, then we have to use the double angle identity again. So cosine of 4 theta, that is equal to 4 theta. Cosine square 4 theta, that is equals to 1/2. And then that will be 1 plus what? 1 plus 8 theta. How do I get the 8 theta? So to get the 8 theta, then that will be, if you recall the identity right here, the double angle, there is a 2 built in right next to the theta, right? So since this is a 4, then that will be 2 times 4 theta, that is equals to 8 theta. So that's how we get the 8 theta. And then we do a rewrite. And then we have integral 1 over 4, and then 1 plus 2 cosine 4 theta. And then we write the square, that becomes, we can distribute that at the same time. Oh, I wrote 8 theta only. That should be cosine of 8 theta. All right, so that will be a 1/2 plus 1/2 cosine of 8 theta distribution. All right, this piece goes right over here. Distribution, distribute the 1/2. And then you can see that you have a 1 plus 1/2. Okay, now we are ready to integrate. Let's keep the 1/4 outside. So we have 1/4, and then the integral of 3 over 2, which is 3 over 2 theta, the integral of cosine of 4 theta, that is equals to sine of 4 theta. There is a 1 over 4 in front of that, and then the 2, this 2, we keep the 2 on top. And then plus, this will be sine of 8 theta. There is a 8 down here, 1 over 8, and then we also have a 1 over 2. So that's the answer, right? So, and then you distribute the 1 over 4, so that will be 3 over 8 theta plus this will be 1 half, so 4 times 2 is 8. And then sine of 4 theta. And then we have 2 times 8 times 4, so that will be 8 times 8, 64. 64, so plus 1 over 64. And then we have sine of 8 theta, and then you plus c to it. So that is the answer of the third integral. Alright, so that is the end of this video. If you think I picked the best problem and provide you with the best explanation, let me know in the comment below. Like the video, share the video for me, subscribe to my channel if you haven't done so. Appreciate your help and support. See you all in the next video. Signing off for now.